Hello, hello, I'm David Diaz and I'm the Just IPFS and Just libp2p tech lead. And I welcome you to the first libp2p overview talk. It is actually a preview, but one that should bring a lot of clarity to all of the libp2p contributors, users, and stakeholders. I welcome all kinds of feedback. My goal is to have a talk that we would be proud to deliver at a tech conference. So let's get to it. The agenda is quite straightforward. I'll start by explaining the motivation and why do we need to think about networking in 2018. After that, I'll jump right into libp2p, what it is and what it does, followed by a progress report, and last but not the least, I'll talk about what it is in the horizon for the project. If you have been following IPFS for a while, you might have heard us describe all the web, the platform that we love and learn to rely on. It's pretty fragile, and that it has several design problems, most of which come from location addressing. And now the solution is to move to a content addressed model. However, what doesn't get explicitly said is that in order to give content addressing properties to the web, you have to go deeper into the networking stack and overcome many of the challenges that the current internet infrastructure has. Things like firewalls that apply too restrictive filters, NATs that blind peers from each other, high latency networks that make the experience horribly slow, networks that are just not reliable and keep failing, the lack of mobile addressing across different types of networks and protocols. This is also known as roaming. The fact that there are governments that can completely shut down the internet for entire countries, and lots of devices with very different connectivity properties, forcing developers to work really hard around their limitations to get connected with each other, and a lot of times they are just simply not able to. Also, really important, innovation in networks land is incredibly slow. It takes years for a new protocol to go down the OSI stack and to be deployed in a large scale. Even orgs with huge amounts of funding might still take years to decades to deploy new fantastic ideas to the internet's fabric. In order to build IPFS, the peer-to-peer file system, we had to come up with ways to work around these limitations, some of which required to redesign pieces from the ground up. The fun fact is that IPFS is not the first peer-to-peer protocol. Actually, there are multiple projects and some have been around for decades. If you have been on the internet biz for a while, you might remember when Skype was originally launched, it was a peer-to-peer voice service. Projects like Nutella, Kazaa, Emul, BitTorrent, and others enabled file sharing in a peer-to-peer fashion. There was a lot of academia research that got published, some of which got implemented, others didn't. And even though these projects existed before, it was epically hard to really leverage the work done in the past. Most of these projects have the classic software reusability problems. Things like lack of good documentation or none at all, licensing was too restrictive or nowhere to be found. The projects were old, some of them really old with a last update more than a decade away, and they simply didn't work in modern OSs or modern language runtimes. No maintainer to be seen, the source was closed or the source didn't exist anymore. This is very common in academia where the source is not seen as something valuable and typically gets thrown away after the paper gets published. The specification was missing and the implementations didn't expose a really friendly API that was easy to use and play with. Most of these projects were tightly coupled with a specific use, making it very hard to adapt. And this is something that we still see today. A fun example is WebRTC, the peer-to-peer transport of the web platform. WebRTC is so incredibly hard to piece together that more than 5 teams of open source hackers or companies have tried and continue trying to extract the source code from the Chrome browser and repackage it to other runtimes. And still today, most of those implementations are quite buggy, they are not well maintained, and simply not reliable. Another common pattern across these past projects is that there were a lot of assumptions made, probably for the sake of productivity at the time, but now it makes them really hard to adapt. So there had to be a better way. And I know what you're thinking, the famous XKCD 927 on the standard story. But no, think about it. What if instead of creating a new standard, a new project that is competing with the old ones, we actually created a project that is a frame, a toolkit full of options to integrate all of the previous ones and the ones to exist in the future? Well, enter libp2p. libp2p is a modular networking stack designed for the modern problems of networking, and that is future-proof. libp2p is the networking stack of IPFS, but extracted out, making IPFS one of its dependents, and opening the space for many other projects to use and innovate with it. Making libp2p a first-class project, meaning that it has its own ecosystem, objectives and priorities, teams and stakeholders. A simple way to think about libp2p is if IPFS brought content addressing to the world, libp2p brings process addressing, a way to find, connect, and authenticate processes so that we know we can trust a connection end-to-end. libp2p is a collection of building blocks that expose very well-defined, documented, and tested interfaces so that they are piece composable, swappable, and with that, upgradable. Another way that I like to describe it is by saying that we grabbed the OSI vertical layer system and made it horizontal. By the way, just to page in everyone's mind, the OSI layer system, although being the one still taught in many networking classes, doesn't actually represent well all the networks. TCP/IP got deployed worldwide, and so its model is a better representation. Either way, both of them are just conceptual, and in practice, they do have shortcomings, such as multiple actions that are repeated through many of the layers, duplicating work and wasting resources. Information gets hidden, missing significant opportunities for optimizations. If you are new to these ideas, I strongly recommend you going through the RFC 1958 and RFC 3439 on Internet architecture, principles, and guidelines to improve your understanding. The summary is that what happens today is that the Internet protocol spread over multiple layers, which made things very tightly coupled internally and hard to change and to innovate. libp2p changes this and just gives you a frame in which all of these protocols can coexist and cooperate. You pick your own libp2p recipe, and if at a time you want to change, you just have to change the recipe, but the top-level API, the libp2p API, remains the same, so your app doesn't need to change. A good example of this in practice is how IPFS runs in Node.js and in the browser. Here you can see each recipe. The differences are that both runtimes have different capabilities, different transports, and so in Node.js we get to use TCP and WebSockets, while in the browser we use WebSockets and WebRTC. To learn more about each of these pieces and how they work and how they plug together, you can check the very comprehensive tutorials in Just libp2p repo. These spec explanations with code samples that you can try on your own. So this is libp2p. What about progress? How far have we gotten? So far, we have 3 language implementations, one in Go, one in Rust, and one in JavaScript. And one slowly in the works in C# by a community member, and many pieces built in multiple other languages thanks to multi-formats, the self-describable data types that are extensively used in libp2p. The community is growing fast, with over 70 contributors dedicated to libp2p and over 1,000 people that have participated in the project somehow. It runs on the browser, and this was kind of the test of fire for libp2p. And in addition, it also runs on mobile browsers, which is super exciting. It has enabled apps like collaborative doc editing, thanks to libp2p publish subscribe API for real-time communication. We demoed libp2p connecting Go Ethereum nodes to Ethereum VMs running on the browser using libp2p to transport the blocks from the Ethereum chain. There are also new products that do peer-to-peer live streaming using libp2p. And our friends at MetaMask are doing tons of research on how to leverage libp2p to deliver blocks faster to their giant user network. And of course, any project that is using IPFS is using libp2p by design. And in the future, any project that will use Filecoin will also be using libp2p. Another pair of exciting news is that the Ethereum project is actively exploring the migration to libp2p networking stack. And at the same time, Polkadot has committed to use libp2p and have made significant progress, and with very exciting results, connecting browsers to their network using libp2p. And of course, let's not forget that libp2p has a gorgeous website logo, something quite rare for a networking project. So let's talk about the timeline. And disclaimer, this timeline is highly speculative. It is a mix of what is possible and what are our wildest hopes and dreams. It only serves the purpose of giving some notion of direction. So use it with that in mind. Somewhere in the next 3 months, the priority is to support the 3 language teams and help them achieve feature parity with robust integration and interoperability testing that should be projected out of an up-to-date specification of libp2p. Also, to improve the debugging ability, and overall excitement, we want to have a way to visualize different network topologies. This will also be essential to foster innovation. 6 months in is where we see that wild adoption will kick in. We want to see new language implementations, or even better, libp2p getting packaged on the language runtimes. So it's just there for every single developer. We also want to have a packet switching API. Today, all the APIs are stream-based, which work pretty well for the use cases that we have today. But for high latency and low bandwidth connections and really non-reliable connections, packet switching can bring significant improvements to the experience of the users that use libp2p. And yes, we also want to get some new transports such as Bluetooth. More in the future, we want to make libp2p an OS level service and a kernel module. We want to promote tons of innovation in networking, go to university networking courses, researchers and labs, and help them explore it in depth and build on top of it. We also want to go into radio and use all of the latest and greatest software-defined radio software to create radio modules for libp2p. The long-term goal is really to make libp2p the go-to peer-to-peer networking stack and convince the world that there is no need for the client and server model and all of its limitations. Infrastructure is more reliable when it is built with protocols that are fully distributed and can adapt to many networking scenarios. Still, lots of work to be done, but something that we can do together. Thank you so much for your time. I hope this presentation was valuable. Please send your feedback to david@protocol.ai. Thanks so much.